Thank you, everyone, for joining to today's session, Azure OpenAI for Education, a use case scenario. My name is Luis. I am a Microsoft MVP from Mexico, but I live in Czech Republic, so we are quite close to you. I hope that you find this session interesting. Because, well, we are going to talk, of course, right, about the technology that is everywhere, right? You have heard about ChatGPT, about OpenAI, at least once per day, right? If you go to social media, there is something about generative AI, right? So, well, I am a developer, and I say, well, why not to apply this technology into something that I also love, which is teaching, which is education, right? So we're going to talk about capability of GPT models, or all this technology, which is known as RAG, or Retrieval Augmented Generation. The idea is that these generative AI are very smart. They were trained, right, with um, millions of data. They are known, or GPT is part of the LLMs, large language models. So, of course, they have millions of sources and blogs and source code, right? But if you ask a question about your data, it can't do it on its own, or it will fail. But thanks to this technique known as RAG, there are others, of course, you can connect your AI models to your own data. So they ground, or they reference a specific files, maybe sources of data, could be your PDF files, images, right? And the response, the answer that the GPT model generates is grounded. It has this reference. So we are augmenting the capabilities of the AI model when it delivers an answer. Okay, so let's talk a bit about how this RAG capability with Azure OpenAI allows us developers to use these models to work with our data, right? And let's say we've also created a mobile application that showcases this. All right, so most probably you have interact with these GPT models, maybe using ChatGPT, maybe using the playground if you have an Azure account, right? And the main, let's say, input is the prompt. We provide, as users, or in some application, a message that tells the GPT model what we want. However, this prompt, or if you are using chat completions capability, there is also an important part of it, which is known as the system message. The system message defines the behavior of your model, of your AI. You can tell it to answer answer a question with a joke, right? So if you are asking, what's the largest planet in the solar system, the GPT model, of course, it will tell you that it's Jupiter, but it will also include a joke around it, right? Like, didn't you know, or something like that. Right? This system message, you can also customize it to, for example, present the information in JSON format, right? We can define the format of the output. We can include maybe some examples, the size, like, okay, write a paragraph, 3 bullet points, maybe even specify in Spanish, in English, right? So that's let's say that's a plus from the user's input, right? The user will focus on the question, right? On its idea, right? And the system message will help to deliver in an expected format because maybe you use that output in your application. You want to extract the result in JSON format, right? And do your thing in your application with your code. And well, yeah, you can also include some other maybe characteristics to that behavior. Maybe add some barriers, right? Some limitation, even though it is quite powerful around the content safety, right? But still, we can also add more barriers, more limits. So yeah. Now, as I said, this works with maybe factual information until the point where the GPT model was trained, right? Because these models have some training data until some date. And if we ask it for recent data for our own data, it will fail. It might even tell you, well, you are asking me something about recent facts. I don't know because my training date was until this very specific month, day, year. So I cannot answer. I know that at the time the answer was this, right? So if we want to augment the capabilities, improve the results, so it works with this maybe new data or our own files, there are different techniques. Some of them are easier to implement, require some effort, but the quality might not be what we expect. Maybe you have heard about prompt engineering, right? Which is a technique that revolves around prompts that, yeah, we are very descriptive in these prompts. We might even include a paragraph where the answer is, but we want GPT to extract it or to infer something, right? So this is, of course, an easy and also cheap solution because you only pay for the tokens, input tokens, and the output, of course. But on the other hand, it requires you to provide that data, and you don't, right? You are not going to provide the text of a 100-page PDF in as part of the prompt. So then we have other techniques. Fine-tuning is a powerful one, but expensive, really expensive. Training a GPT model can be as costly as maybe $40 per day because maybe 35 US dollars is for the training and the rest is for hosting your new model. Fine-tuning is basically providing files or information to a GPT model and train over this new data. So you will produce a new one, but this operation is costly, is expensive, right? Of course, the cloud can do it for you, maybe OpenAI or also Azure, but you will pay a lot. On the other hand, yeah, you might get what you expect. And in the middle, we have retrieval augmented generation. So this characteristic, we will describe it in a minute, but this one, it involves some other services, some other help, but you get nice results or with high quality around it, right? So yeah, and of course the most let's say The top one would be to train a model from scratch, but of course, you know that that one will be difficult, will be expensive, because you need, if you have millions of data, well, yeah, you can do it. But then you also need all the infrastructure that is required for that. Okay, so what is RAG? What is Retrieval Augmented Generation? So the idea is that these GPT models will be able to reference to specific sources of information in order to ground the response, that the user knows, yeah, this answer was generated because the data was in this file, for example. It could be a specific data, right, provided in this pre-trained knowledge, or maybe it's knowledge, the knowledge, the model, sorry, the knowledge that the GPT model had before. We can specify that in the system message, for example, like only use your new knowledge, right? Don't rely on what you knew before. So this can create more effective responses. This technique, which I will detail in a few minutes, connects pre-trained models like GPT 3.5, GPT-4, and newer versions to your own data sources. In the case of Azure OpenAI, we need an Azure AI search resource that will ingest the data, that builds an index, and also performs a vector search or semantic search, which we'll mention in a minute. From let's say from our files. Maybe we have some information in blob storage or in a Cosmos DB database or an SQL database, right? Probably you have heard about AI search. So that's a powerful resource, or service that can get the relevant information based on a user's query. And yeah, so we're going to connect our Azure OpenAI resource to a search index, which is also connected to some data source, like a storage account. The idea is that the Azure OpenAI resource receives the user input, determines what's the relevant content from the question, what's the intent of the prompt, what does the user want. They want to summarize some text. They want to generate, in our case, it will be, generate a quiz based on some documents. So once the GPT model, because the GPT model is really smart at extracting these entities, relevant content, intent, it will pass those terms to a search index. A query will be generated, and the search result will be returned back to Azure OpenAI to generate text, right, according to the prompt, the user's prompt. And then back to our application, and we do what we want. Sorry. Okay. You will see how we do it. So what happens internally, right, between the data extraction, like, okay, how does a GPT extracts this data, the user's intent or the query itself? It does it through embeddings. An embedding is a special data representation format. It is known as a dense representation of the information that contains, for example, the semantic meaning of a piece of text. Each embedding is a vector. You can see it's an array of floating point numbers. And this is how the GPT models can map content to a specific semantic space. GPT models, you might believe, right, that they work only with text. In fact, they work with numbers, with the embeddings, right? Yes, it is true that we provide text and we get text, right, in the output. However, the GPT model uh, converts this text into numbers, into embeddings, right? There is process of tokenization, and so yeah, that's also involved, but it works with the numbers. So yeah, as you can see, we provide some text, and there is an embedding model which converts or represents this information as a vector. And this vector might include some context, like, okay, if we're talking about, I don't know, porcine pulse, maybe we're talking about France, about agriculture, well, not agriculture, maybe a farm, right? There will be relevant pieces of information. And there is a nice model, which is known as ADA, right? Which is quite smart at generating the embeddings of text. So it can generate the embeddings of our input and also the data sources. Actually, this is the process, right? How does an LLM find things? Well, not only our query, but also the data, the files that are stored somewhere are converted into embeddings through an embeddings model. Because, as I will explain in the next slide, there are some techniques, there are some methods to find which embeddings from the data are quite close to the embedding of the user's query. If we are working with numbers, we can measure the distance, for example, between our embedding of the user of our query, right, and what we have in a store in the vector database, because it will be expensive if all the sources are embedded every time that there is a query from the user, right? Well, what is better, or what happens, is that actually at some point, all the data is converted into embeddings, and that information is stored into a vector database. So the process, the embedding process happens every time that we run an indexer, right? Again, if you have heard about Azure Search, you know this indexer is the process that ingests the data, extracts the relevant pieces of information. In this case, the embedding is also there. So when a new query is received, only that one is converted into embeddings, and then we have some techniques to search what are the embeddings that are close to what the user asked. Yeah, there are some techniques, and the most used is cosine similarity, because it measures the cosine of the angle between two vectors projected in a multidimensional space. Here you can see it with 2 dimensions, but actually there can be many dimensions, but it is easier to understand maybe with 2. Azure OpenAI embeddings use this cosine similarity to calculate how similar are the documents that we have, right? Maybe we have 2 PDF documents. You can see document 1, Obama speaks to the media in Illinois. And document 2, the president greets the press in Chicago. And of course, there will be much more text. Maybe those are only the headlines, the title, right, of some news. So the idea is that this when a new query arrives from the user, maybe The query was what was Obama's speech about, right? So if we are doing maybe a text search, it will look for the words Obama, speech, maybe the place, right? And maybe here you can see that speech, that keyword does not exist. So that, of course, will maybe reduce the score of this one happening. And maybe if we said also Obama, the second document doesn't talk about Obama. It says the president, right? So we need some context, or the context is helpful. And I will go through that in the next slide. But here you can see that the cosine similarity means that these documents can be related somehow because, for example, the term Obama is close to president. It knows, right? Because of the context. If we're talking about Chicago, okay, Chicago is close to Illinois. Media and press are quite connected. But on the other hand, for example, Obama is far from media. And also from press, right? Because maybe here we are talking about people and the role of that people. Here we are talking about places, and somehow, for example, the distance between Obama and Illinois is, let's say, shorter than Obama from media, because of course he was the president of the US. So somehow places around the US could be closer than other terms, right? Yes. So if two texts are similar, the vector representation will be also similar. And the embeddings are, let's say, correlate the elements with semantic similarity. And actually, that's what is recommended to use something called semantic search, because that one doesn't look for exact words, instead for words that are similar. That you can say, okay, those words mean the same. So if we say the president, or if we say Obama, right, they are highly correlated. They are the same, even though the word is not mentioned. It can infer that it means the same, right? Also Illinois, Chicago, and other things, right? So the results of this semantic search are text with embeddings similar to the user's query. Right. Okay, yeah. So the distance is close. They are correlated. Inputs are, again, almost the same. If two texts are similar, the vector representation must also be similar, right? And yeah, this is the process, and I will just not repeat it, right? But yeah, essentially, everything is vectorized, is converted into embedding. Again, an index extracts the relevant pieces of information, and then we can search on it. So this is the same diagram, but now replaced with some specific data. Maybe our data was YouTube subtitles. Maybe we have 100 videos, and we got the subtitle of each video. And then all these subtitles were embedded, converted into embeddings at some point. So we have that information into vector databases. So now there is a new query from the user. What is Azure ML? So thanks to embeddings models, thanks to semantic search, right? The GPT model will retrieve those vectors, those YouTube subtitles, which are similar, or which include the term Azure or machine learning. Sorry, yeah, even though the user mentioned ML, thanks to its knowledge, thanks to its capabilities, it will know that maybe some video talks about Azure machine learning, and that one will be retrieved because even though we are not using the same keyword, the semantic meaning is similar, is the same. Maybe another one talks about cloud machine learning, right? Cloud and Azure are highly related, right? Yeah. And we can store this data over different providers, right? Of course, we can use Azure Search, Cosmos DB, PostgreSQL, but there are others. Pinecone is also quite popular or quite well known. Okay, so we are running out of time almost. Yeah, but this is the last slide, right? Because now I have the demo. So the last slide is that these embeddings work by chunking the data. There are two types: fixed size and context aware. Fixed size means that maybe it creates these chunks. It converts the embeddings for every paragraph. Right? Every paragraph is a new embedding, a new chunk. Or the other one could be the GPT model will know, okay, I will group maybe several paragraphs because they are talking about the same, right? So that's context aware. Anyways, enough talk. How do we do this? All right. So for that, we are going to work with the Azure portal. And yeah, let's do that. Okay, rather than just showing some slides, I have the portal here. Okay. So what we are going to do is that, first of all, let's, you know what? Let's start with Azure Storage. Okay, I'm going to create a resource group. Okay, no, sorry, resource group. Yeah, sorry for that. Resource group. And okay, let's say Global Azure Poland, and I'm going to use some regions, even Central, because it has a lot of capabilities. I think this one should be nice. Okay, maybe I will just add this RG. Okay. Here I'm going to create 3 resources. I mentioned through the presentation, right? I will start with an storage account. So because I want, right, to place the data there, and I will show you the information that we are going to work with. Okay. So here, let's say Global Azure Poland storage. And I don't need redundancy. To simplify things, I will enable anonymous access, so I don't need to provide a shared, a SAS token or something like that. And the rest is okay. And I will create. Okay. So what am I going to do? Through an application that I developed, maybe let's say that I have a PDF document with my notes, right, from some topic. In this case, it is about HTTP communication, HTTP methods, requests, responses, and so on, right? So the idea is that I'm going to upload this document into a storage account. However, this document will be uploaded in chunks, right? Every 1 page for every chunk. I will show you in a minute, because here I just need to create a container. Let's call it documents. And I will provide anonymous read access for blobs only. Okay, and now I need the access keys so I can upload my code, right? So this is a storage account name, and I have my application here. Okay, let's say, okay, I don't need this. I have the connection string, yes. Okay, okay, so I'm going to replace this thing, right? And let's run this application. I will show you the rest later, of course. This is a .NET MAUI application, and I will shared. It's already uploaded to GitHub. I will share it in a minute. The link where you can find this. So it's open source. You can customize it as you need, as you want. Right? And the idea here is that I'm going to upload that document. So it is here. Yeah, this one. And it will take some time because, as I said, it will extract every page of this document and upload it. This is a recommendation, right? So it is also easier for the GPT model to extract relevant data for each page, right? And you can see in our storage that this was already uploaded. So blob containers, documents, and yeah, every page is there, right? Only, yeah, okay, whatever. Yeah, no need to, okay, or just test it. Yeah, this is only one page. Perfect, nice. What's next? Now we're going to create an AI search resource. So I'm going to create a second one here. Let's say in that resource group, service name is GA Poland search and Sweden Central, same region. Basic tier should be enough for this small demo. And yeah, okay. Then let's click on create. And I'm going to need three things, which are the keys and also the endpoint of this search resource. I'm going to update this, and that index will be created later. Okay, good. So this one is already there. Let's go to the keys. We have the primary key. Yeah, this one, search key, and the query one. And the endpoint is in the overview. Okay, now how do we connect this? Well, we need to create a search resource. Sorry, an OpenAI resource. So here, let's do it. Hopefully I have enough quota to do that. Okay, same region where I have my data. The resource name will be GA Poland OpenAI standard pricing tier, and yeah, the rest is fine. Okay, good. Hopefully it doesn't take a lot of time. And eventually I will update this key and also this endpoint, right? So, and I will deploy a model. Okay. In the playground of the OpenAI, I cannot. In the meantime, while this is there, right? We're going to use this characteristic of the playground. Add your data. There is a button, add a data source, where we will be able to choose, for example, blob storage. And we will get a new, let's say, wizard, where we select the storage account and also the search resource. And we create an index. And that one will extract, will do the, we will also create another model, which is the embeddings, right, for what we mentioned before. So the playground will do that for that. Will do that for us, and then I will talk you about the application that we are creating. Right. So before I go to the AI Studio, I'm going to grab my key and upload it here. Yes, and the endpoint. The endpoint is here. Okay. Now we have the deployment. Okay, so we have to go to AI Studio. we need to create a deployment. It could be GPT 3.5, GPT-4. Let's see if I can use GPT-4. It depends on the quota that I have available. For sure, I think I can create a GPT 3.5. Let's see, GPT-4. Yeah, I can. Okay, update default deployment name. I will stick to GPT-4 name, right? And the rest, it's not a problem. Okay, perfect. So I just need to use this name, GPT-4. Perfect. Now, let's go to the playground. And here we have this add your data. We can ask a lot of things, and maybe you have watch a lot of presentations about this. I will not test anything in the playground, but I will use the wizard to connect everything that I created, right? So we have the data source, and I will choose storage, Azure Web Storage, from this subscription. The resource, Poland storage, yeah, this one. I select the container documents where I have my data, and the search resource, which is this one, right? Then I can create an index name. So I will use this one, which is what I have on my application already, but you can use any name. And here the indexer schedule. For example, I will do it once because I already have my data there. But if you know that you will upload documents every time or so often, you can have an indexer to run hourly or every 24 hours. The indexer is the one that ingests the data and also does the embeddings part. We will do that in the next slide, in the next part. Yeah, okay. Well, actually, for some reason, I cannot add vector search. I know what, because I forgot to create the embeddings one. I told you that we would create a second one. So yeah, sorry for that. Let's do text embedding. The name is embeddings. Yeah. You can use any name. Yeah. Sorry for that. Let's go back to the playground of the GPT-4. Add data source, below storage. We have the storage, we have the container. I select again the search, and we got the index, docs-index. Okay, and now I can add vector search, which I mentioned earlier, right? To find similar or related elements. I select my embeddings model. This is the chunk size that I mentioned almost at the end. Chunking is the process of breaking down your documents into smaller segments for search and retrieval. Yeah, we have vector search or hybrid. Hybrid means that it also considers keywords, right? If you want to search over your specific text, right? But vector is nice because you don't need to use exact keywords, right? I will stick to keyword, but you can do hybrid, right? Also, we can talk about that one later. Okay, 7 close. And now this ingestion takes some time, right? And this will be, let's say, everything that we will do here in the portal. But the idea is that it generates embeddings, it extracts the relevant information. And now I think we can talk about the application. So, because I just need to check when this process finishes. But in the meantime, I will explain about this application. The idea is that we are going to generate, let's say, exams or quizzes, right? Maybe you are a professor and you want to create some exam for students about a specific topic. So this application relies on the answer, the output that GPT-4 in this case does. First of all, it has a very small system message. Here you have it. You are a smart AI assistant that helps professors to generate multiple choice exams of a specific topic. But I have also a long prompt. Limit your responses to information obtained from the documents. You will present the output in JSON. in JSON format, there are specific fields, number, content, option A, B, C, right? Why? Because later because I asked it to generate JSON, right? I actually in the choices, right? I get JSON, which I can deserialize into this model, ID, topic, question, citations, right? Because I ask it to ask questions. And what do I have in question? You can see content, number, option A, option B, option C. Yeah, of course, I spent some time fine-tuning, sorry, I spent some time tuning this prompt so it worked for my specific case scenario. You can add more fields if you want, right? Correct option, reference, and actually it immediately understood the purpose of this. I didn't have to explain what is option A, what is option B, what is reference, what is correct option. It inferred that from its skills, right, or previous knowledge. I also tell it to tell me which one is the correct one. So this one is here, correct option, answer, right? Okay. So thanks to these two, and also, of course, the support of this capability, which already finished, I can now, in my application, create a new exam and provide a topic. So maybe the topic will be HTTP methods. And let's click on generate, for example. Right. I will show you the code in a minute. Maybe you are also interested in that. But this is the, let's say, high level part of it. And I can go in details as much as you want. But you will see the result, right? So it takes some time when it, because it can fail or crash sometimes. But I know that because it immediately tells you I couldn't do it. But when it takes time, it means that, yeah, it worked. So the rest is, well, I work with the Azure OpenAI SDK. Maybe I can later change this or use semantic kernel, which might simplify a lot of things, a lot of communication with the OpenAI, right? But maybe something new is that besides sending a chat completion request, you also need to tell the request that we are using an extension, in this case, cognitive search. And you can see that I have some information like search endpoint, index name, the key of the search resource, which I already connected before, right? And also the query type. It could be simple, it could be complex. There are different types, right? So you can, yeah, and this is the result. And if this is taken from my notes, right? Because of course, if I directly ask, generate a quiz, HTTP methods, right? It knows, but I want to only do it for a specific data. And here, which HTTP method is used to delete a specified resource, right? So maybe I know this is it, and others, I will just select random things, right? And well, the rest is not related with OpenAI, but I can just evaluate. You got 1 to 3 answers. I can ask it to reveal the correct answers because this one is already provided by the GPT model because of my prompt. And you can see the result is in green. Yeah, the correct answer. And it also provided the reference. Sorry, this one is in Spanish, right? But yeah, I can click on it and it will tell me, yeah, that question comes from this document, which is chunk number 10, right? And another one, maybe, or maybe they are from, yeah, this one is from document 8, right? So it is easier to also get the reference from one single document, I mean, one single page rather than a long, because if let's say by default, it will prompt you to that document. And if the document is 20 pages, it will not tell you exactly in this paragraph. No, it will just tell you this is the document and that's it. It will not tell you the exact location. So it is easier to locate also with single page, right? So essentially is that. And then the rest, I have some other things, but this is .NET MAUI, this is C#, generate a PDF that you can provide to students, right? But also a student can use this because of the evaluate part. It can ask you, okay, I want to study, I have this document, generate some questions, then you try, you can evaluate. Yeah, you can do a a lot of things here, right? But yeah, it is essentially that. The rest is just the communication with the service. I do something about storing the data locally, but the communication is in this exam service class. Again, I will tell you in a minute the source code, what is this information. And you can see that, for example, here I extract the result, the choices. If you have worked with the OpenAI SDK, you know that the result is in choices, right, in the message. And then this message is deserialized, as I said, because I know, or this is generated with JSON. Maybe I can even, you know what, I can add some breakpoint here. So you can see, maybe we can ask about, I don't know, HTTP request, right? Maybe. Oh, yeah, sorry. I have to create a new exam. Let's say if there is something, okay, not sure why, whatever. Okay, let's see. And you will see that the data is in JSON, right? And then deserialize, and the rest is just your C# programming skills, right? And well, yeah, just extracting the information and so. So, not sure. Are there any questions? Because this is almost like the end of my presentation. Yeah, okay, so here it is. And you can see content, it's JSON, it's text, right? Because in the end, the GPT model gives you text, but now what do you do with that text, right? So yeah, this is from there, and the rest is about extracting the data working with C#. Not sure. Any questions?
So thank you, Luis. I don't see any kind of questions on the YouTube channel, so I think the topic,
in the meantime,
the topic
yeah.
is something new from most of the people. The OpenAI is like, it's a big revolution, but in the end, not all are familiar with this one. So maybe there will be another questions after the session. Some kind of questions will be. So
I can provide the link in the private chat. So if you want to share it also with the audience about this repository, probably because I presented this, the prompt is in Spanish, but I can push a new update because I work or generate exams in Spanish, but it's nothing difficult or hard. I just have to translate the prompt and also the system message, and that's it. But yeah, here you have, if you want to explore it, feel free to send me a message, communicate, raise an issue if you find something there. I'm happy to collaborate about this.
Thank you, Luis, for your time. Thank you for your presentation. Hope to see you soon, maybe in some kind of meetups or some kind of conference. So thank you for joining us and have a nice day.
It was a pleasure. So enjoy the rest of the conference and good luck, everyone. Thank you again. Bye-bye.
See you soon. Bye.